Hello, today we start with two variants of a distribution problem. And to begin with, let's say let x, y, and z be integers. And the first question that we'd like to address is the following. How many solutions are there to the equation x plus y plus z equal to 8, subject to the condition that all these three unknowns are greater or equal than negative 5. So what we're going to do is a little transformation. What I'm going to describe is the following. Um, all that I want to do is to transform this into a sequence of constraints. The one that looks like x is greater or equal than negative 5, y is greater or equal than negative 5, and z is greater or equal than negative 5. But this is the same as to say that x plus 5 is greater or equal than 0, y plus 5 is greater or equal than 0, and that z plus 5 is greater or equal than 0. Now, if I incorporate this information, then I can construct the sum of these three terms, and I'll write it in this fashion: x plus 5 plus x plus y plus 5 plus z plus 5 equal, well, I'm going to group things. I'm going to have x plus y plus z plus 15, but I know that the sum of these three terms should be 8. So this is nothing else but 8 plus 15, which of course results in the following: 23. Okay, now what may be the use of this new equation? Well, if I put parentheses here, I can introduce new variables. One that is u equal to x plus 5, another one that is v equal to y plus 5, and lastly w equal to z plus 5. Now we can see that u, v, and w are integers where we have that u, v, and w are greater or equal than 0. So now this is just an original distribution problem that looks like this: u plus v plus w equal to 23. And of course, this reminds us of the stars and bars problems. We have 23 stars and we have 3 individuals, so we need 3 minus 1 bars to distinguish them. So we construct a sequence, right? A binary sequence of stars and bars of length 23 plus 3 minus 1. And on that sequence, we select 3 minus 1 spots to place our bars. So this becomes the following count: C of 23 plus 3 minus 1, comma, 3 minus 1, which of course we can reduce to C of 25, comma 2. Okay, now, based on this observation, we may do something similar for the next problem. It says, how many solutions are there to the equation x plus y plus z equal to 15, where x is greater or equal than 2, y is greater or equal than 3, and z is greater or equal than 4. Well, we make the following transformation. What would be that transformation? Well, would be, I'm going to set u to be x minus 2, v to be y minus 3, and w to be z minus 4. once we do that, right, we see that U, V, and W are greater or equal than 0, integers, and based on the condition that we have here, that turns into U plus V plus W equal to x minus 2 plus y minus 3 plus c minus 4, which of course I can group into x plus y plus z minus 2 plus 3 plus 4, which of course I know this is given by 15 minus 9, which is 6. Okay, so now I look at my equation, my equivalent equation, which now is among 3 individuals. I need to distribute 6. Well, how would the count be? Well, just as before, we have, in this case, 6 bars, 6 stars. We have 3 minus 1 bars. And out of this, we construct a binary string of length 6 plus 3 minus 1. Well, let's do it. So the total count would be, we choose among this many places, 6 plus 3 minus 1. You choose 3 minus 1 to be bars, which now you may reduce to C of 8, choose 2. Okay, so is there a different way of doing this problem? Yes, of course. You can think of this as balloons that you need to distribute among 3 children. You may start the process like this. Distribute or give 2 balloons to the first child. Give 3 balloons to the second child. Give 4 balloons to the 4th child. And that would say that you have to distribute now 6 remaining balloons among X, Y, and Z, the children. But that is exactly the same count. Okay, that would finalize the discussion. I'll see you next time.